Okay, dear students, so till now we have done all the projectile motions, but we have not considered the fluid resistance as of now, till now, isn't it? So let us find like what is this fluid resistance now. So let me use this board now. So let us say there is this ball, and this ball is moving under the influence of gravity. So there is weight which is acting on this ball. Okay, so what happens is when it is moving through the fluid, there are two forces acting on it, like in the upward direction. Two forces, or total there will be three forces. So one force is called the buoyant force, the upthrust, and the other force which is acting in the upward direction is the drag force. Now, but for this point, like we are not introduced with the upthrust, isn't it? Like this is about the fluid, and so the fluid motion we have not yet done, and so that will be done like later. So upthrust is not there, so we will not be talking about the upthrust as of now. But when you talk about the Stokes law, like if you have done some IA on this or something you have chosen, so Stokes law, that law formula is derived only by using the fluid physics, also by using the upthrust force also, but we are not considering in this video. Later we will be doing it later sometime, but not now. So we are considering only the drag force in the upward direction. And this drag force which is happening here, this drag force is found to be directly proportional to the velocity of the body with which it is moving. It could be given that no, it is not velocity, it is the square of the velocity. Well, that is a possibility. If somebody tells you no, it is the cube of the velocity, even that is a possibility, because that depends upon the various shapes. So even that is okay. So whatever is given to you, like v square or v whatever, so what we do, we say that the drag force is equal to a constant k and v is multiplied. I'm considering v square here, but that is not required. No problem. The book is not considering it. So Fd is equal to kv. Let us say for lower velocities it is kv. For higher velocities it becomes v square. So Fd is equal to kv. So this is the drag force which is happening here. Now, what is the phenomena which is taking place? Let us now imagine that there is a body which was dropped from a height. Now it is moving. So initially the velocity is zero. So body is moving with the zero velocity. It means that initially there was no drag force. There is only one force, and that is the weight. Weight is having a constant magnitude. Neither it is decreasing nor it is increasing. So it is the constant magnitude. But this drag force is increasing with time. Okay, so it is moving with the velocity v, and the drag force is increasing, which is kv. Gradually the velocity starts increasing. So as the velocity builds up, the drag force also starts becoming bigger and bigger, bigger and bigger. But the weight is constant, but the drag force is now increasing in its magnitude like this. So the drag force is increasing. After some time, the drag force has such a velocity that the drag force magnitude comes equal to W, that is weight. Now at that time, the net force which was acting on the body earlier, that becomes equal to zero, and thereby the acceleration of the body becomes zero, and thereby we can say that now it is moving with a constant velocity, because no longer it is having an acceleration, although it is being acted upon by acceleration due to gravity, but there is a counter force which is balancing the weight, which is balancing that force, and that is why the f net is zero, and so the body is not moving with an acceleration anymore. So the body is not increasing its velocity, so now the velocity becomes constant. That velocity is known as terminal velocity. How to find this terminal velocity? Obviously we will just equate these two forces. So we will say that Fd is equal to the weight, which is mg. From here you can find the velocity, which is coming out to be mg by k. Either the k value be given to you, or some other thing will be given to you. Okay, you have to find, or something will be there, but no worries about that. Like what is the value of k? It is not a constant value, it will be given to you in the question. So v is equal to mg by k. and this v is written as vt, just to uh, just to denote terminal velocity, we can say. Okay, so terminal velocity is mg by k. If v square is there, we will take the square root of this. V cube is there, we will take the cube root of this. Accordingly, we can find the terminal velocity. Now, the whole of the story that I have told you, like now the velocity is increasing, drag force is increasing, we can draw the graphs for this and we can understand like what is happening in these graphs. Okay, so I would be showing you the graphs now. Let us move to these. These graphs are very, very important. Okay. Okay, let's see now. Now, this is the first graph that you must understand. And IB is asking you questions from the graph. So graphs become very, very important. This is the velocity with which it is moving. And this is the time. So you can clearly see that initially the velocity is very high. Velocity is zero. Velocity is zero, but the slope is very high. The slope of a vt graph that I have already told you, it pertains to acceleration. So acceleration is really very high, which is 9.8 meter per second square initially. So it is moving with this much of the velocity, with this much of the acceleration. So velocity should be increasing. So it is increasing, but the rate at which the velocity is increasing is decreasing. Why? Because the acceleration is decreasing throughout. We can say that it would be undergoing an acceleration which is given by f minus fd divided by the mass m. Now, as the fd is increasing, the f net is reducing. So clearly, the acceleration is reducing. So initially, the acceleration was approximately equal to 10, which is actually 9.8. So we can see very steep decrease, very steep reduce in the acceleration. So it is reducing very high, and then it is becoming horizontal after some time. Okay, what is happening here? The acceleration has now become zero, so that definitely the velocity is now becoming constant. So this is the terminal velocity that the body has attained, which is 30 meter per second. From the graph we can read it and we can say that yes, the terminal velocity achieved will be 30, and the acceleration is becoming zero. Why? Because the f net is now equal to zero. This is f net. So this is the graph for the acceleration, very important, which is reducing. So the rate at which velocity is increasing is reducing. Velocity is still increasing because acceleration is still positive. Point to be noted: acceleration is positive but reducing. So it means velocity will be increasing but at reducing rate. I hope I am clear now in these two diagrams. Okay, dear students, so these two diagrams are important. This is not of that importance. So this is what is the drag force, and accordingly we can find the terminal velocity. I repeat, kv is equal to mg. So vt can be written as mg divided by k. This is it for this video, my dear students. So this is Professor Varun. Thanks for joining, and please share the video with all your friends. Okay, all the best. Bye.